When sizing Romex conductors using table 310.16, it's important to understand which insulation type to reference for ampacity. Romex, also known as non-metallic sheathed cable, typically uses conductors with THHN or THHW insulation inside the outer jacket. However, when using table 310.16, you must use the temperature rating of the wire insulation to correctly determine the ampacity. Romex is limited to 60 degrees Celsius or 140 degrees Fahrenheit for ampacity determination per the National Electrical Code, NEC, Article 334.80. This is regardless of the insulation rating of the individual conductors within the Romex cable. Therefore, when using table 310.16, you would select the column that corresponds to 60 degrees Celsius for Romex. Table 310.16 provides ampacities for various conductor sizes based on their insulation temperature ratings. These ratings specify the maximum temperature a conductor can withstand under normal operating conditions without degrading its insulation. Common insulation types include THHN, THHW, THW, and XHHW, each with different temperature ratings. For example, THHN and THHW are typically rated for 90 degrees Celsius in dry locations, but their ampacity must be adjusted based on the termination temperature limitations. To correctly use table 310.16, firstly, identify the conductor size you plan to use, for example, 12 American wire gauge, AUG, or 10 AWG. Secondly, determine the temperature rating of the conductor's insulation, keeping in mind the 60 degrees Celsius limitation for Romex. Thirdly, locate the corresponding ampacity value in table 310.16 at the intersection of the conductor size and the appropriate temperature rating column. The ampacity value represents the maximum current in amps that the conductor can safely carry. For example, if you are using 12 AWG Romex, you would look at the 60 degrees Celsius column to find its ampacity. Remember that the 60 degrees Celsius ampacity for 12 AWG copper wire is typically 20 amps. Similarly, for 10 AWG copper wire, the 60 degrees Celsius ampacity is typically 30 amps. If the ambient temperature is higher than 30 degrees Celsius, which is 86 degrees Fahrenheit, or if there are more than 3 current-carrying conductors in a raceway or cable, you may need to apply ampacity correction and dilating factors as specified in the NEC. These factors reduce the allowable ampacity to prevent overheating of the conductors. The NEC provides specific tables and formulas for calculating these adjustments. The NEC Article 310.15 covers ampacity calculations and adjustments in detail. For example, if you have full current carrying conductors in a Romex cable, you'll need to apply a dilating factor to the ampacity listed in table 310.16. This ensures that the conductors don't exceed their temperature rating and cause a fire hazard. It's also crucial to consider the termination temperature ratings of the equipment to which the conductors are connected. Equipment is typically marked with its termination temperature rating, such as 60 degrees Celsius or 75 degrees Celsius. You must select conductors with an ampacity that is appropriate for the lowest temperature rating of any connected equipment, terminations, or the conductor insulation itself. This ensures that no component in the circuit exceeds its temperature rating. For example, if you are connecting a 90 degrees Celsius rated conductor to a circuit breaker with a 75 degrees Celsius termination rating, you must use the ampacity corresponding to the 75 degrees Celsius column in table 310.16. Always consult the latest edition of the NEC and local electrical codes for specific requirements and regulations in your area. Electrical codes can vary by jurisdiction, so it's important to stay informed of any updates or changes. Also, it is crucial to understand the difference between conductor ampacity and circuit breaker or fuse ratings. The conductor ampacity determines the maximum current the wire can safely carry, while the circuit breaker or fuse rating protects the conductor from overcurrents. The circuit breaker or fuse rating should not exceed the conductor's ampacity. In some cases, the overcurrent protection may be smaller than the conductor ampacity depending on the application and specific code requirements. For example, a 12 AWG copper conductor with a 60 degrees Celsius ampacity of 20 amps should typically be protected by a 20 amp circuit breaker. Overcurrent protection devices such as circuit breakers and fuses are designed to interrupt the flow of current when it exceeds a certain level. This protects the conductors and equipment from damage due to overloads, short circuits, and ground faults. The NEC provides specific rules for selecting the appropriate overcurrent protection device for a given conductor size and application. When installing Romex, be sure to follow all manufacturer's instructions and NEC guidelines for proper installation techniques. This includes using appropriate cable staples, maintaining proper spacing, and avoiding sharp bends that could damage the conductors. Also, ensure that the Romex cable is adequately supported and protected from physical damage. Improper installation can lead to insulation damage, short circuits, and other electrical hazards. When working with electrical wiring, always prioritize safety. Turn off the power to the circuit before working on any electrical components. Use appropriate personal protective equipment, PPE, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Working with electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others. Always double-check your work to ensure that all connections are secure and that all components are properly installed. A thorough inspection can help identify any potential problems before they become a safety hazard. Remember that electrical work requires knowledge, skill, and attention to detail. By following the NEC guidelines and best practices, you can ensure a safe and reliable electrical installation. When referring to Table 310.16, always consider the specific conditions of your installation, including the ambient temperature, the number of current-carrying conductors, and the termination temperature ratings of the equipment. These factors can all affect the allowable ampacity of the conductors. It is also essential to differentiate between different types of conductors and their corresponding insulation temperature ratings. For instance, THHN conductors are commonly used in dry locations, while THHW conductors are suitable for both wet and dry locations. The NEC specifies the allowable applications for each type of conductor. Understanding these differences is crucial for selecting the appropriate conductors for your specific application. In addition to Table 310.16, the NEC contains other tables and articles that provide guidance on conductor sizing and installation. For example, Table 310.15b3 provides adjustment factors for the number of current-carrying conductors in a raceway or cable. Article 310 covers general requirements for conductors for general wiring. These resources can help you make informed decisions about conductor selection and installation. Always consult the latest edition of the NEC and local electrical codes for the most up-to-date information. Electrical codes are constantly evolving, and it's important to stay current with any changes or updates. Also, consider the long-term reliability and performance of your electrical installation. Selecting high-quality conductors and components can help ensure that your electrical system operates safely and efficiently for many years to come. Proper maintenance and periodic inspections can also help identify and address any potential problems before they become major issues. When working with electrical wiring, it's always best to err on the side of caution. If you are unsure about any aspect of the installation, consult with a qualified electrician or electrical inspector. They can provide expert guidance and ensure that your electrical system meets all applicable codes and standards. Also, remember that electrical work is not a DIY project for everyone. If you lack the necessary knowledge, skills, or experience, it's best to leave the work to a professional. Electrical work can be dangerous, and it's important to prioritize safety above all else. If you are hiring an electrician, be sure to check their credentials and references. A qualified electrician should be licensed and insured, and they should have a proven track record of providing safe and reliable electrical services. Also, ask for a detailed estimate before work begins, and make sure that the estimate includes all labor, materials, and permit fees. Before starting any electrical project, it's a good idea to create a detailed plan. This plan should include a list of all materials needed, a step-by-step procedure for completing the work, and a timeline for completing the project. A well-thought-out plan can help you stay organized and avoid costly mistakes. In addition to following the NEC guidelines, it's also important to follow any manufacturer's instructions for the electrical components you are using. Manufacturer's instructions often contain specific information about installation, operation, and maintenance. Following these instructions can help ensure that the components perform as intended and that they are installed safely. Also, consider the environmental conditions in which the electrical wiring will be installed. If the wiring will be exposed to moisture, chemicals, or extreme temperatures, you may need to use special types of conductors or enclosures that are designed to withstand these conditions. The NEC provides specific requirements for wiring in hazardous locations, such as those containing flammable gases or dusts. In these locations, it's important to use explosion-proof equipment and wiring methods to prevent ignition of the hazardous materials. Also, be aware of the potential for electromagnetic interference, EMI, in your electrical installation. EMI can disrupt the operation of sensitive electronic equipment. To minimize EMI, use shielded cables and enclosures and follow good grounding practices. The NEC provides guidance on grounding and bonding requirements to minimize electrical noise. In addition to safety and performance, consider the energy efficiency of your electrical installation. Using energy-efficient lighting, appliances, and wiring methods can help reduce your energy consumption and save you money on your electricity bill. The NEC encourages the use of energy-efficient technologies and practices. Also, consider the future needs of your electrical system. If you anticipate adding more electrical loads in the future, it's a good idea to install a larger service panel and conductors than you currently need. This will make it easier to expand your electrical system without having to replace major components. Remember that electrical wiring is a critical component of any building. A properly designed and installed electrical system can provide safe, reliable, and efficient power for many years to come. By following the NEC guidelines, using high-quality components, and working with qualified professionals, you can ensure that your electrical system meets all your needs and expectations. Also, consider the importance of regular electrical inspections. A qualified electrical inspector can identify potential problems before they become safety hazards. Regular inspections can help ensure that your electrical system is operating safely and efficiently. The NEC recommends periodic inspections of electrical systems, especially in commercial and industrial buildings. In addition to inspections, it's also important to perform regular maintenance on your electrical system. This includes checking for loose connections, damaged wiring, and other potential problems. Regular maintenance can help extend the life of your electrical system and prevent costly repairs. The NEC provides guidance on maintenance procedures for electrical equipment and wiring. Also, consider the importance of electrical safety training for employees who work with or around electrical equipment. Proper training can help employees recognize and avoid electrical hazards. The Occupational Safety and Health Administration, OSHA, requires employers to provide electrical safety training to employees who are exposed to electrical hazards. In addition to the NEC, there are other standards and guidelines that may apply to your electrical installation. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, IEE, and the National Fire Protection Association, NFPA. These standards provide guidance on various aspects of electrical design, installation, and operation. It is also important to understand the difference between grounded and ungrounded electrical systems. Grounded systems provide a low impedance path for fault current to return to the source, which helps to protect people and equipment from electrical shock. Ungrounded systems do not have a direct connection to ground, which can make them more susceptible to voltage surges and other electrical problems. The NEC specifies the requirements for grounding and bonding electrical systems. Also, be aware of the potential for arc flash hazards in your electrical installation. Arc flash is a dangerous electrical explosion that can cause serious burns and other injuries. To minimize arc flash hazards, use proper personal protective equipment (PPE), and follow safe work practices. The NEC provides guidance on arc flash hazard assessment and mitigation. When working with electrical wiring, it's important to use the correct tools for the job. Using the wrong tools can damage the wiring or create a safety hazard. Make sure you have a good set of wire strippers, pliers, screwdrivers, and other essential electrical tools. Also, be sure to keep your tools in good condition and replace them when they become worn or damaged. In addition to using the correct tools, it's also important to use the correct materials for your electrical installation. Using substandard materials can compromise the safety and reliability of your electrical system. Make sure you use only high-quality conductors, connectors, and other electrical components that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories AL. When installing electrical boxes, be sure to use the correct size and type for the application. Electrical boxes provide a safe enclosure for wiring connections and protect them from physical damage. The NEC specifies the requirements for electrical boxes, including their size, material, and location. Also, be sure to properly support electrical boxes and raceways. This will prevent them from sagging or becoming damaged over time. The NEC provides guidance on supporting electrical boxes and raceways. When running electrical wiring through walls or ceilings, be sure to use appropriate wiring methods to protect the wiring from damage. This may include using conduit, cable trays, or other protective measures. The NEC specifies the allowable wiring methods for different types of construction. It is also important to understand the difference between branch circuits, feeders, and services. Branch circuits supply power to individual loads, such as lighting fixtures and receptacles. Feeders supply power from the service to one or more branch circuits. The service is the connection between the utility power grid and the building's electrical system. The NEC specifies the requirements for branch circuits, feeders, and services. Also, be aware of the potential for voltage drop in your electrical system. Voltage drop occurs when the voltage at the load is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, use larger conductors or run shorter wiring distances. The NEC provides guidance on calculating voltage drop. When working with electrical wiring, it's important to follow all safety precautions and use common sense. If you are unsure about any aspect of the installation, consult with a qualified electrician or electrical inspector. Remember, electrical safety is everyone's responsibility.